Hey everyone, welcome to this video on troubleshooting IPv4 routing. This is part one of this three-video series on troubleshooting IPv4 routing. So in this lesson, which is multiple videos, three videos, we're going to be covering these exam topics from the blueprint. So network access and IP connectivity. So we've got 2.8, describe network device management access, telnet SSH, HTTP, HTTPS console, TACAX plus radius and cloud managed, and then IP connectivity, configure and verify IPv4 and IPv6 static routing, default route, network route, host route, and floating static routes. So this video, right, is going to be five parts. So the breakdown of this lesson will be that we're going to be covering these five in this lesson, in this video. So the ping command basics, extended ping in iOS, which performs a better test of the reverse route, testing LAN neighbors with standard pings, testing LAN neighbors with extended pings, and then testing WAN neighbors with the standard ping. And then in the following videos, we'll be looking at DNS configuration commands and comparisons between ping and trace route. So firstly, let's look at ping command basics, right? Ping command basics. So I'm pretty sure everyone watching was familiar with ping, but just a definition of ping is that it's a command utility that's used across various operating systems for testing the availability of the device with an assigned IP address. Okay, so we can use it in Windows, Linux, Mac OS terminal. We can use this in Cisco iOS and Junos. Several operating systems, we use the ping utility. Now it stands for Packet Internet Groper. Packet Internet Groper, so just and it uses a series of ICMP, Internet Control Message Protocol messages. Sorry for about that there. ICMP, not CIMP. Internet Control Message Protocol messages. Now, on Cisco routers, a ping, right, that means 5 echo replies within 2 seconds. Okay, so there are limitations to ping, and I'm going to go into the limitation of standard ping very shortly, but let's look at extended ping. So extended ping, you might have heard of ping, but you might be thinking, what is extended ping? Well, extended ping, the problem with a standard ping is it doesn't test the reverse route. But when we use the extended ping, we can perform a test of the reverse route. So by entering ping, literally just ping, this allows us to do an extended ping, and that's more intrusive than the standard ping because it allows you to ping out to an external subnet. And I recommend everyone tries this in a lab, but I'm going to show you now. So if we were to just type in ping on router 1 here, it gives us basically like a series of options. So we specify the target address for router 2, 203.0.113.2, and then we specify the source address, which is router 1's interface. Going into the interface for router 1, and we can see here that the pings were successful. So that's all great, right? They were successful, but this did a test of the reverse route as well, which is really, really good. Now, if we talk about testing LAN neighbors with standard pings, you'll see that, for example, here, this is a standard ping. Now, standard ping is only going to give you, you only can only test so much, because, for example, here, we want to do, if we want to ping from route 1 to host A, which is this laptop here, if we want to ping the IP address of host A, we can do that. It sends out an echo request, and then host A will send out an echo reply. Okay, but this will only test so much. Now, but if the ping works, it rules out potential issues that could be happening in this LAN. For example, that we know that the host with the destination IP address, i.e. host A, that can reply. The LAN can pass unicast frames from route 1 to host A's IP address, and the fact that ARP being completed between these two as well. If you had a switch in between, then you can reasonably assume that the switch is able to that basically the switch has the it's got it knows about both in its table. Now that's testing line neighbors with standard pings. If there was this ping though was to fail, we could have a problem because a failure of a standard ping can mean that it can be several issues. So, for example, the IP address is wrong, either on the host or the router. It's actually configured the wrong IP address for some reason. For example, like an APIPA on hosts, we see this a lot, especially in the Windows environment, where we have sometimes hosts pick up 196.254 automatic IP address. So that can become a problem. That will, if we do try and ping the host's IP address that we expect it to have, and it's got 169.254 IP address, then it's going to fail. That ping will fail. An IP subnet mask mismatch, that can also be a problem. If we've got the subnet mask between the host and the router in the same LAN, I haven't got the same subnet mask configured, that's going to be a problem. DHCP issues, VLAN trunking not being configured on all the routers and switches in the route. For example, if you've got ISL trunking or 802.1q trunking, 802.1.2.q trunking is what we use mostly nowadays. But if we were to have it just configured on the router but not the switch, then that's a problem there as well. That can stop the pings from happening. Layer 2 switch issues as well. So if we look at now testing LAN neighbors with the extended ping, like I said, it's more intrusive. It's more valuable test of the connection. Okay, it's able to ping an external subnet, unlike the standard ping. So, for example, here, if we are on router 1 here, and we were to go onto the terminal and then ping 192.168.1.31, which is the IP address of this host, if we were tempted to ping it from this interface here, right, that ping goes to host A. Host A then tries to send an echo reply to router 1, and it knows that it's sending to a different subnet because its IP address is 1.31, right? But the source IP address was 4.1. So that's in a different subnet to host A. Host A recognizes that, it sends the echo reply, and it actually reaches that ping, that interface. So this extended ping allows for us to ping an external. It allows us to ping an external subnet here. Okay, route 1 has pinged an external subnet. Host A was able to send an echo reply to an external subnet. So that's the power of an extended ping. Now, if we test WAN neighbors with the standard ping, if I were to show you here on this whiteboard, you've got host A here connected to switch 1, connected to router 1. Then between router 1, you've got the internet, and then you've got router 2. Okay, so this here's a WAN link. Okay, and then you've got switch 2 and host B. Now, if your IPv4 addressing is properly designed, two routers that are connected over serial or Ethernet WAN link should have IP addresses belonging in the same subnet. So, this represents a serial Ethernet WAN link here. Okay, so this is a serial Ethernet WAN link here. You got router 1 and router 2. So if router 1 was going to try and ping 172.16.5.2, which is the IP address of router 2 here, that's in a different subnet. It sends an echo request, and then router 2 sends out an echo reply. So this is they're in different subnets, but you can ping over a WAN link just doing a standard ping. Okay, this is a standard ping, but you can ping over a WAN link to a different subnet if the IP addressing is properly designed and implemented. So this is what's happening. So, and this lets us confirm several things. It lets us it establishes that the router WANs are both in an OPUP state. The interfaces are in OPUP state. Both router WAN interfaces are in an OPUP state. The layer 1 and layer 2 features of the link are working, and the fact that the remote router, that point hasn't been fully typed up. The inbound access control list, the ACLs, on both routers are not filtering the incoming packets, and the fact that the routers understand that the neighboring router's IP address is in the same subnet. So that is pinging over a WAN link, and that brings me to the end of this video. So thank you so much for watching. I'm sorry about part 2 and part 3. I'll get these out as soon as I can, and also please watch out. There'll be a video about verifying IP parameters on Windows, Mac, and Linux coming up. So please keep a lookout for that video. I'm getting that out as soon as possible. Sorry, it should have been released today, but there's fortunately been a bit of delay, but I'm going to get that out as soon as I can for you guys. And then obviously there's more videos coming out, as you can see in the schedule. If you follow me on X, or if you just look in the community section of my YouTube channel, it's there, so you can see the schedule. So I'm doing my best to get these videos out as soon as possible in the timely manner for you guys, as per the schedule. Apologies here, there's a bit of delays here, so I do apologize for that. But thank you so much for watching. If you like the content, please like, share, and subscribe, and I'll see you in the next video. Thank you.